Good afternoon, my dear student. Previous sessions we have discussed about the expression for amplitude modulations and sideband frequency and bandwidth and disadvantages of amplitude modulations. This is the earlier classes we discussed about it. Today we have discussed about the frequency spectrum of amplitude modulations, frequency spectrum of frequency modulations, and difference between the amplitude modulation and frequency modulations. Now first we have discussed about the frequency spectrum of frequency modulations. First we know that already amplitude modulations is defined the maximum distance that is vary, which means the amplitude is varied. In the case the frequency and phase becomes a constant. We have to know that the frequency spectrum. What is the frequency spectrum? The number of oscillations of the per second, that is the frequency spectrum. Variations, number of oscillation is varied. In the case of sideband frequency we have to define the in the case of modulations. There is a two sideband frequency are there. First one is the upper sideband frequency, we have to define the USB, and the second one is a lower sideband frequency that we have to define the LSB. So on the basis of sideband frequency ranges, to take the frequency spectrum, there are the several frequency or several complex wave with their relative amplitudes. Number of frequency wave will travel to the same direction accordance with the time with the relative amplitude. This amplitude wave is known as the frequency spectrum. We have to know already the equations of amplitude modulations. Already yesterday we have discussed about the equations. See the equations. Em is equal to EC cos omega CT plus MA EC divided by 2 cos omega C plus omega S into T plus of MA EC divided by 2 cos omega C minus omega S into T. This is equations of the amplitude modulations. We have to take this equation to find the spectrum which contain the amplitude modulations varied in the case of modulation factor, because frequency spectrum of amplitude modulation varies, which depends upon the values of modulation factor. We have to see the, you have already told that earlier classes, that is EC cos omega C plus T is a carrier voltage, MA EC divided by 2 cos omega C plus omega ST is the upper sideband, and second one MA EC divided by 2 cos omega C plus omega minus omega S is the lower sideband. We have to define omega C or minus omega plus omega S is equal to FC minus FS, or omega C plus omega S is defined as the lower sideband ಅಂತ ಹೇಳಿ ನಾವಿಲ್ಲಿ ಡಿಫೈನ್ ಅನ್ನ ಮಾಡಿದೆವು ಆಲ್ರೆಡಿ. Then these equations to take, this is carrier, this is upper sideband, and this is the lower sideband, that we have to define in the case of the modulation factor M is equal to 1. The modulation factor M is equal to 1. The 100% modulations will be proceeded on the spectrum range, because the frequency spectrum of modulated wave represented by the equations. We have to see the equations. Phi is equal to M Vc divided by 2. We have to see that equations. That equation, the modulation factor M is equal to 1, then we get the 100% modulations will be proceeded. In the case the Fc plus Fs and Fc minus Fs, this is Fc plus Fs is the upper sideband, this is Fc minus Fs is the lower sideband, and Fc is the carrier frequency. EC is a carrier frequency, MEC divided by 2 is the upper sideband frequency, and MEC divided by 2 is the lower sideband frequency. Then the distance between the to sideband frequency which is known as the bandwidth, that is defined as the bandwidth. Fc plus Fs minus Fc minus Fs is equal to 2Fs. So we have to define the bandwidth of the amplitude modulations waveform is twice the signal frequency. Twice means this type the wave formations in the modulations factor. So we have to define which is on the basis of the bandwidth and sideband frequency. So which is known as the frequency spectrum of the amplitude modulations. And the second one is defined as frequency spectrum of frequency modulations. Amplitude modulation which is works on the frequency spectrum, and already frequency modulations is under process of the frequency spectrum, so it is easily proceed of the frequency modulations because the frequency spectrum which related to the frequency modulations. So the point will be seen that the first point, the frequency spectrum consists of carrier component together with the sideband frequency which are harmonics of modulating signals. There are these also which contain the sideband frequency ranges which component harmonics of the modulating signal. Harmonics of the modulating signal means which is varied the upper and lower. We have to see the harmonic pressure. This goes to the decreases. See the diagram, and first one we have to see the diagram, and this is the cases. Fc is a carrier voltage, and Fc plus Fm, Fc plus 2Fm, Fc plus 3Fm, Fc plus 4Fm, Fc plus 5Fm, which means the distance amplitude is varied. It means the amplitude means the oscillations will be varied. The amplitude and the phase becomes the constant. So we have to define in the case of upper sideband frequency and lower sideband frequency, the maximum carrier frequency to the minimum carrier frequency which goes to the Fc, Fc minus Fm, Fc minus 2Fm, Fc minus 3Fm, and Fc minus 4Fm, and Fc minus 5Fm. So we have to take the consider of the equations of the sideband frequency are separated from the carrier wave from Fm, 2Fm, 3Fm, 4Fm, 5Fm up to etc. It goes on the 6Fm, 7Fm. So it is a decreasing of the oscillation. So we have to define the frequency spectrum means the oscillations will be in the case of frequency will be varied, then the case the frequency and the amplitude and phase become the constant. So we have to define the recursion frequency is frequency modulation, the sideband frequency that are on either side of the carrier and at equal distance from equal amplitude, hence the frequency spectrum is symmetrical about the carrier frequency. The amplitude is equal, so we have to define the frequency spectrum of the frequency modulation. This is a process of the frequency spectrum of frequency modulations. And the next one, difference between amplitude modulation and frequency modulation. Easily we have to write the difference between the AM and EFM. First one, what is the first one difference? Definition: the amplitude is varied, the frequency and phase remains constant. Same, the frequency modulation varied, the amplitude and phase becomes constant. Easily we have to definition. Second one, it varies the modulation index from 0 and 1 because modulation factor which depends upon the amplitude modulations. Its modulation index is always greater than 1. Its modulation index is always greater than 1 because this is a over modulation. So we have to take the greater than 1, the frequency modulations which we varied the amplitude modulations of the modulation factor. And the third one, it has only two sidebands. It has an infinite number of sidebands. We have to see the already diagram. We have to see the diagram. it has only two sidebands, upper sideband frequency and lower sideband frequency, that is MVC divided by 2, MVC divided by 2, and FC plus Fs and FC minus Fs is equal to 2Fs, that is known as a bandwidth. But the frequency modulation, it has an infinite number of sidebands. If we have to see FC, FC plus FM, FC plus 2FM, FC plus 3FM, FC plus 4FM, FC plus 5FM. It means the variation, the oscillation will be decreases. The amplitude of the carrier wave of the distance becomes constant. And the next one, it has a simple circuit. It has a simple circuit and it is a complex circuit. Amplitude modulation has a simple circuit and it has a complex circuit. And the next one, the amplitude of the carrier wave is modified in order to send the data or informations. Amplitude modulations verify ಮಾಡಿದ್ರಿ and send to the data and informations. The frequency of the carrier wave is modified in order to send the data or information, which is also same informations and the data will be sent. And next one, it requires low bandwidth in the range is 10 kilohertz because there is only two sidebands. And it requires high bandwidth if the range is 200 kilohertz because the infinite number of sidebands. And the next one, in amplitude modulation received the signal is a low quality and frequency modulation received the signal is a high quality. Amplitude modulation is a distance, so it is a constant low quality. Frequency modulation, its range is hertz, so we have to take the high quality of the signals will be carried. And the next one, it works in the frequency range 535 to 1705 kilohertz, and frequency modulations range is 88 to 108 megahertz. So it is the quality is high and it is the quality is low. So it's a frequency range with double to the frequency modulations of the range will be high. So that is the comparison. And the next one, it operates the medium frequency and high frequency. And amplitude modulation, it operates the medium also and high frequency, and the frequency modulation only high frequency because its the frequency range is high. And the next one, it has poor sound quality, it has a better sound quality, and bandwidth twice the highest modulating frequency. 2Fs we have two equations. Bandwidth twice the sum of the modulating signal frequency and the frequency deviations. There are the twice of the modulating signal frequency will be there and the deviations will be there, because deviation means the number of oscillations will be varied, that is up to infinity number of oscillations will going on the frequency modulation. So frequency deviation in the process of the bandwidth of the frequency modulations. And the last one is more susceptibility to noise, less susceptibility to noise, because the has a poor sound quality, so we have to noise become the more susceptibility. This has a better soft quality and sound wise quality is a smooth, very high frequency signal, so less susceptibility of the noise. These are the difference between the amplitude modulations and frequency modulations. These are the concept of the amplitude frequency spectrum of amplitude modulations, frequency spectrum of frequency modulations, and difference between the amplitude modulation and frequency modulations. This is the concept of the modulations of the frequency modulations and amplitude modulations. And this is the last concept of the modulations. Next class we will discuss about the demodulation process. What is the demodulation process? Need for the demodulation process, how to work on the demodulations in the case of super heterodyne receiver. Okay, thank you students.